Hello, this is Electrical Circuits tutorial series, part number 5, series circuit analysis. We'll be discussing the actual calculations, how to use the Ohm's Law and Power formula to get the expected value, the baseline that we'll use when we go and measure our live readings. We can compare it to this. So we'll be using a very simple 3-load series circuit in this case. The first, using resistors as our loads. The first one, R sub 1 is at the top, R sub 2 is at the right, and R sub 3 at the bottom. So we need to first take and trace our circuit, make sure there's only one path to the current to flow. And it goes through the first one, there's still just one path, all the way through 3 loads back to the power source with only one path for the current to flow. So this is a series circuit. The values, the known values we've been given is a total voltage of 120 volts DC, and we have our load resistances. R sub 1 is 20 ohms, R sub 2 is 10 ohms, R sub 3 is 30 ohms. So for us to be able to get started and go further, we need to find our total circuit resistance. And if you recall, the series circuit rule states that the sum of the individual resistances equals the total resistance. So R sub t is equal to R sub 1 plus R sub 2 plus R sub 3. So that 20 plus 10 plus 30 will give us 60 ohms total resistance for this circuit. Now that we have our total resistance and our total voltage, we can find our current for this circuit. So I sub t is equal to V sub t divided by R sub t. And so we're going to have our total voltage of 120 volts divided by the total resistance of 60 ohms to give us 2 amps. Now in a series circuit, the current remains constant through all components. So I sub t is equal to I sub 1 is equal to I sub 2 is equal to I sub 3. In this case is equal to 2 amps. So we can populate those other 3 currents for the individual components. Now that we have all of our currents and all of our resistances, we can find our voltage drop. Now voltage drop is simply the voltage that we would measure across a component in a circuit when the circuit's energized. Even when we're reading the voltage of a battery or our power source, we're reading a voltage drop. It's the total voltage, but that's all a voltage drop is. And so to do this, we'll use Ohm's law. And so V sub 1 is equal to I sub 1 times R sub 1. Now I know our current remains constant in a series circuit. However, we use a specific current for the device or the component that we're talking about. That way we don't get confused when we switch from a series circuit to a parallel circuit or to the combination series parallel circuit. And so we're going to take our I sub 1 of 2 amps times our R sub 1 of 20 ohms to get a 40 volt drop on that first load. Our second load will be V sub 2 is equal to I sub 2 times R sub 2. So I sub 2 is 2 amps. R sub 2 is 10 ohms, giving us a 20 volt drop. V sub 3 is equal to I sub 3 times R sub 3. I sub 3 of 2 amps times R sub 3 of 30 ohms, giving us a 60 volt drop. Now then, on a series circuit, remember that the sum of the individual voltage drops always equals the total voltage. And so V sub t is equal to V sub 1 plus V sub 2 plus V sub 3. So we add our 40, 20, and 60 to get that 120 volt system. So this is a quick check we can use to make sure that we did our math right, which comes in handy when you get to more complex circuits. Now we need to find the total power and the power dissipated by each individual component in the circuit. And so our power formula is P sub t is equal to I sub t times V sub t. So we're going to take our total amp of 2 amps, multiply it by our 120 volts applied voltage, and that'll give us 240 watts for this entire circuit. Now we'll do the individual power dissipated by the individual components. So P sub 1 is equal to I sub 1 times V sub 1. So I sub 1 or 2 amps times our 40 volt drop, giving us 80 watts for our first load. P sub 2 is equal to I sub 2 times V sub 2. So I sub 2 of 2 amps times our 20 volts of V sub 2 will give us a 40 watt drop at the second load. And P sub 3 is going to be I sub 3 times V sub 3. I sub 3 of 2 amps times our 60 volt drop at the third load, and gives us 120 watts dissipated at that third load. Now the power rule, it applies to all circuits, a series circuit, a parallel circuit, and a series parallel circuit, and it simply states that the power dissipated by the individual components in the circuit will always equal the total power. So we can do another quick check, make sure we got our math right, and so we can take P sub t is equal to P sub 1 plus P sub 2 plus P sub 3. So our 80 plus our 40 plus 120 does give us 240, so we know that we did our math right. These quick checks are real nice to use and everything. That will build your confidence also. So now this is all the calculations that we can find for this particular circuit. We're ready to go out and make our live readings of this circuit and compare them to this and see if it's close, real close, and we're good to go in that part of the circuit. If we're way out of the ballpark, we need to look a little bit closer at that component or that part of the circuit because we have an issue there. This concludes part 5 of the electrical circuits tutorial. Thank you.